Hey guys, welcome to week 3 of the coronavirus CodeReach. So, pretty much the goal of this week is to get the aliens to start to shoot at us and create these 3 shields right here that will defend us against those bullets. So, the first step we need to do is create a list of positions for all the alien bullets. So, this is almost super duper completely similar to the def shoot function that we did last week. So to help break it down for you, first of all, what we need to do is we need to create a list to hold all the bullets. We need a can shoot boolean. So a boolean that regularly tells us to shoot bullets at intervals. So that way we don't have like 100 bullets shooting down the screen at the same time. We also need a timer that can count, like see how here the timer had to be counted up until 150 until a bullet could be shooted again. So we need another similar function to this. And if we were to go on, so if the boolean is true, we're going to append the position of a bullet at the position of a random alien. And then so how do we do that? So there's this really cool function in Python which is called randint. So how basically randint works is randint, and I put in 2 numbers, say like 5 to 100. So what randint does is it randomly chooses a number between 5 to 100. So if we were to randomly choose any alien in the list, we would have to use this randint function to randomly choose one and then append at the position of that alien. As for this, we don't need to worry if key space is pressed or the space key is pressed, because then the aliens are automatically appended. And the same thing here, we need an if else. In the else, we need to include the timer up and then set can true to true, or can shoot to true, and then set the timer back to 0. And then if can shoot, we append the bullet and restart the loop again. So I'll give you guys around 15 minutes to start with this, and then I'll get back to you on how I did it. Okay, so how I did this function, let's see. So the function I called was def alien shoot. And then so what I did up here is I have a list to store all of the bullet positions. Can shoot tells us if we're allowed to shoot. And a timer here is a counter that goes up by 1 every time and helps spaces out the bullets. So if we go to our function, as you can see, it's pretty much the same. I use the same variable names as Arsalan did last week, except for I just had an A underscore in front of all of them. So we first global A timer and A can shoot. So if A can shoot, that means if our Boolean variable lets us shoot. First we find a random alien. So I create a variable called alien. And out of all of the enemy positions list, I chose a random variable or a random number from 0 to the length of the list -1. So why -1? Because of the indexing of the list. If we take the actual length of the list, there's a possibility that we get the very last number. And since the indexes from a list start at 0, we need to take -1 because that would be the index of the very last one. Okay, After I've chosen a random alien, I'm going to append my bullet at the position of the alien. So we append to our A bullets list, and we take the alien's X position, so that's the first thing in the list, so that would be at index 0, and plus 20 because I think our aliens are 40 by 40. So that would be in the middle of the X position. So then if we go to our alien's Y position, that's index 1 because it's the second one in the list. And we want it to be at the bottom of the alien, so we do plus 40. And then we restart this loop by saying A can shoot is false. And then so if we go through this again, if A can shoot is false, we want to increase our A timer by 1. And then so by the time our A timer is increased up until 150, so it's spaced out every 150, then we set A can shoot to true, so then we can go through all of this again, and then our A timer is back at 0. Okay, so our next function is to move all of the bullets again. So this is pretty simple. So what we need to do is we need to loop through all of the bullets. And then we need to move every X position down, or sorry, every Y position down by 1. Okay, so I'll give you guys about 10 minutes to start doing this, and then I'll show you how I did it. Okay, so how I did this function, my function I called def move alien bullets. So for what I did was I looped through all of the alien bullets. So for I in range, the length of the list of alien bullets, and then so for every alien bullet, I get it at I, and then I get the Y position, which is the second one. So that would be index 1, and I move it 2 down every single time. So you take the alien bullets, get the 1 at its I position. So that'll give us a list of 2 elements. And then we take the first index, which is the second element in the list, or the Y position, and we increase it by 2 every time. And then so what I did over here was I deleted all of the bullets that pass the bottom of the screen. So what tends to happen if we don't do this is that we get a bunch of bullets below the bottom of the screen, and we just have them keep on going the whole time, and they're useless to our game. So what I did here is that if the first bullet of the list, so the first bullet of the list is the first one in, so then that means it's going to be the one furthest down. If that is greater than or equal to 600, so if it's at the bottom of the screen, then I delete that bullet. What I put here is I first checked if the length of the list was greater than 0. So if there's any bullets in the list, because if I didn't check that, then this over here would crash and our program would crash. Okay, our next function is to check if one of our bullets hits the spaceship there. And then so how we do that is we loop through all of the bullets again. And then we check if any one of those bullets has hit the spaceship or has hit the player. And then for now, we're just going to print like death or something. As for next week, we'll take care of things as like after you die, we'll show like a screen of like game over, or after you win, we'll show a screen that you win, but we'll leave that for next week. So I'll give you guys 10 minutes to do this again, and then I'll show you how I did it. Okay, so how I did it, I created a function called check death. And some of you guys may have done it the way that Arslan did last week by checking if the bullet was between the corners of the spaceship, and that's all right too. But the way I did it is I made my spaceship into a rect object, and then I used collide point for the bullets. So the first thing I did, I created a variable called spaceship, and out of that, I made a rect from the player's X position, player's Y position, 50 right and 50 down. And then to loop through all of the bullets in the alien bullets. So for bullet in alien bullets, so then we take our rectangle or our rect object. So if the spaceship collides with our bullet, so we need to take the X and the Y of the bullet. So the X of the bullet would be the first object in the list. So that would be at index 0 over here. And then the Y position would be at index 2. So that would be 1. And then for now, we just print died. Okay, so the next thing that we have to do is draw all the alien bullets, and this is similar to this again. So we have to loop through all of the bullets again, and then draw a rectangle wherever the bullets are. So I'll let you guys have another 10 minutes to do this, and then I'll show you how I did it. Okay, so how I did it, I just created a function to draw the alien bullets, and I looped through all the bullets. So for bullet in a bullet, that gives me every bullet in the list of a underscore bullets. So I just drew a rectangle. If you wanted to, you could split an image like for how the spaceship did, but I was too lazy to download an image, so I just drew a rectangle. It's green. I made my bullet green. You can make it whatever color you want. And then, so to get the position of it, the first thing in the list of the bullet is its X position. So it would be at index 0. And then bullet at index 1 would give us the Y position. And I just made it 2 by 5. So our next goal is to get the shields running, right? So there's only 3 shields, so there's no need to loop through and create all of them. I just created all of my shields at the beginning here. So if you look at the shields here, how I created the shields is every shield is a list that contains 2 things. This is the shield itself. I directly made it into a rect object. So every time I loop through it, I don't have to make it into a rect object again. And then it's at position 1, or sorry, this number is how many times the shield's been hit. For now, I use the number 1 because every time the shield gets lighter, I use a division on the color to make it a bit lighter. And you're not allowed to divide by 0, but depending on how you choose to do it, you can either make this number 1 or 0. So if we looked at the rect of the shield, so the top left corner of the shield is going to be at 50, 450, so that's at the left, somewhere near the bottom of the screen. It's 100 wide and 50 tall. And the other 2 are spaced out at the bottom of the screen. So if you look here, they're in these 3 positions. And if you also look, every time that a bullet hits the shield, it gets slightly lighter, and that's what our second number here is going to help us manipulate. So I'll give you guys 2 seconds to copy this shield down here, and then we're going to start our function on how to check if the shield's been hit. Okay, so if you haven't copied this down yet, or haven't finished copying this down yet, just pause the video and then I'll go and throw down the basics of how to do the shield. Okay, so pretty much how the shields are going to work, we have to loop through all of the bullets again, and this time we have to loop through every shield inside of the bullets. Oh, there we go. Loop through shield. And then, so after we're done that, we need to check if the bullet hits with the shield. So we need to check for collision between every shield and bullet. And then after, if it's been hit, we're going to increase this number right here, which is the number of times that the shield's been hit. So increase the number of times the shield's been hit. And then so after that, every shield that has been hit 3 times is going to be going to be deleted from the shields list. So then we need to check if a shield's been hit 3 times. So if it has, then we're going to delete the shield. Okay, so this is a bit harder, so I'll give you guys 15 minutes to work on this, and then I'll show you how I did it. Okay, so how I did check shields. So the first thing I did was I looped through all the shields. So for eye and range, the length of the shields. So the reason I chose to put the shields before the bullets is because first of all, the shields have a lot less in them than the bullets. So if there are no shields at the end or if they all get eliminated, then there's no need to loop through all of it again. So if the scenario where there were no shields left and we put the bullets on the outside loop, then we would just have to go through all of the bullets and there would be nothing there to do it. So it makes our program slightly faster if we loop through the shields first than the bullets in some scenarios, but it doesn't really matter which one you put first. And then so we nest another for loop inside this one. So then we go through all of the bullets here. So then we check if a shield and a bullet collide. Since our shield is already a rect object, we don't need to worry about making it into a rect object. And since shield at I would give us a list with two things in it. We need to get the first object inside the list, which is the 0th index, and that gives us our rect. So if that has collided with our bullet here, and we enter the bullet's X and Y position, which is its 0th and first index, then we would remove that bullet from the length of the bullets, or from the list of the bullets, and then the shield's second number would go up. So, and then to get rid of the shields that have been hit 3 times, remember that my shield started with 1 here. So if it's been hit 3 times, then this number should go up to 4. Here it is. So if we loop through shields again, so if this shield's second number is 4, so if it's been hit 4 times, then we remove the shield from our list. Okay, our next and last function that we have to do is to draw all the shields. And then so how we have to draw the shields, so we have to loop through all the shields again. But this time it's not just simply drawing it, we need to draw it a bit lighter every single time that it's been hit. So we need to draw it lighter every time it's being hit. So how it works is the shield is made up of a color, which I made green. It doesn't really matter what color you make it. And then so we need to reduce this number every single time for the shield to be lighter. And then we need to reduce this number with this over here. So you can either subtract or divide that number every time. So we need to reduce the color in the shield. Okay, I'll give you guys around 10 minutes to work with it, and then I'll explain how I did it, and then that's it for today's lesson. Okay, how I drew the shields. So if we create our function def draw shields here, I loop through all the shields, and then I drew a rect for where the shields are. So if you take a look at this is the color of the shield right here, and this is also why I chose 1 to be my first starting number. So the color is 0, and then this 255 green starts at full green at the start, but as you can see, every time S1 increases, so that's the number of time the shield's been hit. Every time it increases, it divides into 255 here, and it decreases this number overall. So by the time this number grows bigger and bigger, this number will grow smaller and smaller, and then so the shield will look paler and paler every time. And this right here, since S is already a shield, I don't need to define my own rect, and I can just put the rect of S, which is in its first object in the list, which is the 0th index. So I put S0 here, and we're pretty much done everything we need to do this week. And so you should have a program running that looks similar to this.